Hey everyone, and welcome to The Explainer. Today we're going to tackle a tool that really changed the game for software, Docker. We're going to use some simple, everyday ideas to show you exactly what it is, and more importantly, why it's such a huge deal.
All right, let's start with a phrase that I swear every single software developer has either said or heard. It's the classic, frustrating excuse when something that was working perfectly for them suddenly breaks for everyone else. So why does that even happen? Well, the reason is actually pretty simple. Every single computer is its own unique little universe. You've got different settings, different software versions, different tools installed, and all those tiny, tiny differences can cause total chaos.
So, to fix this whole "it works on my machine" nightmare, Docker did something brilliant. They looked for an idea, but not in the world of computers. They looked at global shipping. And this analogy, honestly, makes everything click into place.
I mean, think about it. Way back when, you had to try and stack all this weirdly shaped stuff, barrels, clunky boxes, heavy bags onto a ship. It was a total mess, right? Super slow, stuff got broken all the time. Every shipment was a brand new, complicated puzzle.
But then, somebody had this super simple but totally revolutionary idea, the standard shipping container. And just like that, it didn't matter what was inside, could be furniture, could be food, could be cars. As long as it was inside that standard metal box, you could put it on any ship, any train, or any truck in the world. No surprises. And that, right there, is exactly what Docker does, but for software. It takes your application and every single thing it needs to run, and it packs it all into a standard digital box. We call this box a container. And just like that shipping container, it guarantees that your software will run the exact same way no matter whose computer it's on.
Okay, so how do we actually use these magic boxes? This brings us to two super important ideas in Docker: the image and the container. And you know what? We've got another great analogy for this one. Let's head to the kitchen. So here's the deal. Think of an image like a recipe. It's just the blueprint, right? It's got all the ingredients and all the instructions for making your app. But the container, that's the actual dish you just cooked. It's your app, up and running, ready to go. Yeah, so the key thing to remember here is that the image is just the plan. It's static. It can't be changed. You can't eat a recipe, right? It doesn't actually do anything by itself. It's just the instructions, waiting. But when you follow that recipe, when you run the image, that's when you get a container. That's your app, alive and kicking. And here's what's so cool. From that one recipe, that one image, you can make as many identical dishes, as many identical containers as you want. Okay, but what are these images made of? Like, what's actually inside? This is where Docker gets really, really clever. And for this one, we're going to think about Legos. Everything starts with a simple text file called a Dockerfile. Seriously, this little file is the master plan. Think of it like a step-by-step instruction manual you'd give a robot to build your perfect Lego model. And each line in that file tells Docker to do something very specific. You start from a base, kind of like your main Lego board. Then you copy your own code files onto it, like adding your custom bricks. You run some commands to install other tools you might need. And finally, you give it a CMD, which is just telling the finished model what to do when you press the on switch. And here, this is the truly genius part. Every single one of those instructions, it creates a separate read-only layer. So the final image isn't just one big blob. It's all of these layers stacked neatly on top of each other, just like Lego bricks building a tower, or maybe layers of a lasagna. Now, why does this layer thing matter? Well, it's what makes Docker so incredibly fast and efficient. See, because each layer is separate, if you only change one tiny thing in your code, Docker is smart about it. It doesn't have to rebuild the entire thing from scratch. Nope, it just grabs all the old, unchanged Lego bricks from its memory, we call that a cache, and it only rebuilds the one layer that actually changed. This saves a huge amount of time and space on your computer. Okay, so let's recap. We've got our recipes, the images, we've got our cooked meals, the containers, and it's all built from these super smart, stackable digital Legos. So how does all of this actually fix our original problem? Why is this such a big deal? Well, it really comes down to these four superpowers it gives your software. First, portability. Your container runs the same everywhere. That whole "it works on my machine" problem? Gone. Solved. Second, isolation. Every container is like its own little world, like food in a bento box. They don't mess with each other, which is way tidier and more secure.
Third, speed. Containers start up in seconds, almost instantly. They're not like bulky old virtual machines that have to boot up an entire operating system. And finally, efficiency. Because all those images share layers, you save a ton of disk space and downloads are way faster.
So that brings us to the big question, right? What could you build if your code could just run anywhere, perfectly, every single time? Because that's the real magic of Docker. It isn't just a tool for packing up code, it's a tool that frees developers to build, create, and share amazing things without all the old frustrations. It just works.